Hello everybody, welcome back to the channel. Today we're going to be doing LeetCode question number 152, which is maximum product subarray. So this has a lot of likes compared to dislikes, so that's awesome. So this is a medium question, so let's go ahead and read the prompt and get into it. So it says, given an integer array nums, find a contiguous non-empty subarray within the array that has the largest product and return the product. Goes on to say it is guaranteed that the answer will fit in a 32-bit integer. A subarray is a contiguous subsequence of the array. So for example 1, we have 2, 3, -2, and 4. Our output here is going to be 6 because 2 times 3 has the largest product. And because we're looking for a subarray's, its contiguous subsequence of the array, it wouldn't be 2 times 3 times 4 because, as you can see, contiguous means next to each other. So let's go ahead and let's get started here with coding this out. So I'm going to go ahead, let's see, I'm going to put my test case in here. All right, I'm just going to test case here, and I'm going to say this is what we have as our list. All right, so this is our given list here. And basically the first thing we're going to do to solve this problem is we're going to have to get the min and the max of each product. So the first thing I want to do here is I want to say, we have to basically say if the length of our list is 0, then we're just simply going to return 0. All right, because if it's 0, we're just going to return that number because that would be the output. 0 times 0 is 0, right? And then basically I'm just going to kind of write out what we're going to do, and then we'll get into the coding part of it. So if we have this right here, our list, the first thing I want to do is we're going to have a current. We're going to have a max number or max currently, and then we can have a min currently. Just going to type this out here. So let me just pull this back a little bit. All right, so during our first iteration, we're going to be at 2. So if we're at 2, our current number is 2, and then our max is 2, and our min current is going to be 2 as well. So we're basically going to be doing this for our max and min functions. We're going to be taking current, and then we're going to do our max current times our current, and then our min current times our current. So let's do this way. So this is basically how we're going to be able to find it. Okay, so let me show you. So, all right, so we're here at current. All right, this is step one, right? We're here. And then this is going to be step 2. This will be, oops. Or we can just do the index. So at index 0, at index 1, at index 2, and at index 3. So at index, this is going to be, index. So at index 0, we have this, right? And then let's go to index 1. So index 1, our current is -5, right? And then we're going to do, let's see, so -5. So we're going to do our max current is 2. So 2 times -5 is going to be, oops. It's going to be, let's do negative. So 2 times -5. So -5 is going to be our max, right? Because we know that if we do 2 times -5, our min would be 10. right? And then if we go to the next one, let's see what the next one's going to be. So if we are at current 4, right, at index 2, we're going to go ahead and say our current is 4. Our max is going to be 4 because we know that if we do -5 times 4 and -5 times -10, that's going to be -40. So our min is going to be -40. Last but not least, if we have 0, all of these are just simply going to be 0. So what would our max be? Well, our max would be 4, right? Our output, our max would be 4. So let me go ahead and show you how we do this again. So basically what we're doing here is at each index, we're taking what we have currently, what we have as our max, our current max, times our current, where we're at in our iteration, and then our minimum current times our current max. So as you can see here, when we go to -5, we know that our max that we're going to get is -5, you know, because it's going to take from any of this. Because if we have 2 times -5, that's going to be -10, and we know that's going to be the minimum. So it's basically going to do, we would have right here, we would have, so if we do -5 would be here, and then our max current would be 2, and then this would times -5, and this would do the same thing. So we're going to be using the min and max function, which takes, you know, the largest number from it or the smallest number. So that's why the max current stays at -5. Okay, so let's go ahead and let's code this out. So I want to go ahead and I want to do, we can do current, or yeah, current max. And we're going to set that equal to nums 0. So if we have 2, -5, 4, and 0, this is going to start here, you know, at our 0 index. And if we have current min, it's going to start at the same exact place. And then we're going to create another variable called result, or what we call final result. And we're going to equal that to our current max, so the current max that we have so far. Okay, so let's go ahead and we're going to start iterating. So for I in range, we're going to want to start at index 1, right? Because we're going to be doing, we're going to want to be getting what the current was at the first initial index, which is 0. So for I in range 1, the length of nums, we're going to want to create our current, which is going to be nums of I. So that's going to start off at -5, right? Because we're starting at 1. And then we're going to create a temp variable for temporary max, because the max is going to change, right? So we're going to have max, and we're going to have, just as I showed you when I was just typing it out, current. And then we're going to have max, current max times current. And then let me just move this over. And then we're going to have our current min times our current. All right, and then we're going to go ahead and have our, what is going to be our current minimum. That's going to be the minimum, and we're basically going to take this, copy this, and we're going to go ahead and do this. All right, same thing, right? Because as I showed you in just typing it out, showing you the pseudocode, I guess you could call what it's basically going to be doing. And then we're going to have our current max is going to equal our temporary max. And then what we're going to do is we're going to have our final result is going to equal the max of what we have our current max. What is going to be greater, our current max or our final result? And then simply, we want to just return our final result. So let me go ahead and run this and see if this works. So great, 4, it does work. So awesome. So this is how you do this problem. Let me go ahead and hit submit, and great, 48 milliseconds, which is 93% more than the Python 3 online submissions. The time complexity is O of n, because we're doing linear runtime. Since we're only going through the numbers only once, we only have to iterate through this only one time. And our space complexity is O of 1, because we're just using variables and temporary variables and a placeholder variable for the result. So I hope this was helpful. Thank you so much, and I'll see you guys in the next video.